All right, so today we're going to complete kind of like a cheat sheet, which is basically just a review of all the skills and topics we learned in Unit 3 on angles. So we're going to go in it, we're going to go through it section by section, and this will kind of prep you for the upcoming assessment on the unit. All right, so we're looking at, again, this whole entire unit had to deal with angles. So here's a little picture of an angle. Um, this can also be found in your packet, guys, by the way, so you can follow along and complete it. You're also allowed to use this on your assessment, so very beneficial in both regards. All right, so again, this unit was all about angles. So when you're naming an angle, actually, let me go ahead and finish making my angle here. All right, so there's a picture of my angle. So when we are naming an angle, we use either 3 letters or we can use the number in the angle. So in our example here, it could be angle ABC. Again, you have to go in order of like how you would draw it. So like ABC, or you could say CBA. However, you can't start in the middle and say BAC or something like that. That does not work as far as the order of the letters. So pretend you're kind of drawing it. Or again, if there are numbers, that's the most simplistic way to do that. So in this example, it is labeled as angle 1. Okay, the vertex, it is located in the corner of the angle. So in our example here, we have point B. That is our vertex. If we were going to name sides, again, a side. Sometimes students just say, oh, side A. It's actually this entire side. So just like we did when we're naming the angles, you have to have at least 2 letters to identify it. And you want to kind of pretend like you're drawing it BA and then BC. So we have BA or BC would be the other. And we always want to start at that corner, the vertex, and go out towards the arrow. Location of points. So we looked about interior points and exterior points. Remember, guys, interior is just fancy for inside. So I could put an inside point like E. Or exterior, you meant outside. Again, meaning just outside of the angle. So we could say something like there's point F on the exterior of the angle. All right, so the next section, we learned how to measure angles and we learned how to draw angles. So kind of a quick recap, I'm going to go ahead and grab my protractor. Okay, so if I was, and I don't have another measure or angle besides on the next section, so I'm just going to show you how to use the protractor. So the directions are here. You want to place the center of the protractor on the vertex of the angle. I always mention to you, you put the vertex on the X of the sun, making sure that our line or ray, the side, whatever you want to call it, is in alignment with this bottom line here of our horizon. Then we wanted to read the degrees in the direction that the angle is opening. So again, I always told you to follow the arrow. We always start at 0, so we know if it is opening up to the right, we're using the interior or the numbers closest to the middle. So we go on up until it hits, which would be in this case a 90-degree angle. So then to draw an angle, you're going to use the protractor to kind of make a straight line. So from there, again, I would make a straight line or arrow. Actually, it should be an arrow. And then you would line up, again, the end of your line up with, I'm a little bit off here. And then, okay, so the end of the line on, the X of the sun, and then our line going out along that bottom measurement. Again, if you're moving to the right, you're going to use those interior sets of numbers. Let's say I was measuring 50 degrees. You'd go ahead and make your point at 50 degrees and then rotate that protractor. Again, you can line it up to make sure that you are using, or that you can use it as a straight edge to connect. I'm not doing the best of job maneuvering this protractor on here, but once you have it lined up, then you can take your protractor and again, draw yourself a straight line along there so that you've got nice, clean, crisp lines. So again, those directions are there for you. Hopefully that little tutorial reminded you of how to use that protractor. It's been a little while since we've done that. You're going to also be asked to classify angles. So angles that measure exactly 90 degrees, sometimes they're also indicated by that little box. Those are considered right angles. And again, we compare everything to the right angle. If it is smaller or your angle measures less than 90 degrees, so anything, again, there's a right angle, anything smaller than that is going to be a acute angle. And then anything beyond, so again, here's my right angle for reference, anything that goes beyond, which in this case, that example shows you just what that might look like, it is considered an obtuse. So it's any angle who is measurement is more than 90 degrees. They're going to ask to classify. Okay, then we looked at the angle addition postulate and angle bisector. So the angle addition postulate tells you that if you know, if you have two angles next to each other, so example, if I have this bare little picture here, if I told you this one was 30 degrees and this bottom one was 60 degrees, and I asked you to find the measurement of the largest angle, when you put them together, you would add, and then you could tell that, hey, 30 plus 60 does give me 90. Sometimes you'll have information that says, hey, my whole thing is 90 degrees. Okay, both those angles together are 90 degrees. My top angle here is 30 degrees, so what is my bottom angle? In that case, you're going to subtract. So we could figure out this measurement again by taking 90, subtracting 30, and find out that I have an answer for that bottom measurement of 60. We also talked about angle bisectors. Basically, a bisector is a ray that cuts an angle into two equal parts. So if I have an angle that, let's say, measures 90, if I have a bisector that cuts it in half, okay, 90 degrees, cutting it in half, in order to find the value of both sides, you would divide by 2. So meaning, again, my blue angle is 90 degrees. If I was told the green ray here is a bisector, I would divide it by 2, and 90 divided by 2 is 45. So that's going to tell you, hey, both angles are 45, but they're equal. Okay, adjacent and linear. So adjacent angles, guys, are those, let's see if I can, it's going to be a little bit easier for me to type this out. They're angles that are neighbors. We refer to them as neighboring angles. They share a common side or fence. Actually, make this a little bit smaller there. All right, so as far as a picture goes, there's many different pictures I could show you. I could have something like this, angle 1 and angle 2, they are neighbors and they share this common fence here in the middle. I could show you it upside down, something like this. 1 and 2, they are adjacent. You can also, maybe to give you a completely different, besides just switching the orientation there, we could have something, two very large angles. But again, they're next to each other and they share this common side or fencing. Angle 1 shares the right-hand side with it. Angle 2 shares the left-hand side with it. All right, so a linear pair. Linear pairs are also angles that are neighbors. So meaning that they are adjacent, they have to be adjacent angles, but they have one more kind of factor. So neighbors sharing a fence, kind of how we talked about it in class, but they also form a straight line. Okay, so that's where we get the idea or the term linear. It has that little word line in there. So linear pair would look something like this. Again, I have kind of a straight line, and then I have my fence cutting it into two angles. So I've got angle 1 on the left, angle 2 on the right. But you see that purple line, guys? Those two angles together are linear pair. They equal 180 degrees together. So you're going to be given some pictures and asked to tell me whether they are adjacent and or also a linear pair. Okay, so we talked about complementary and supplementary angles and also a few other references. So neighboring angles, that was just from that last section here, but they are adjacent angles. So again, here are is another picture of adjacent angles. When you have angles that do not share a common side or fence, right? They are simply non-adjacent. We looked at this figure within the unit, and we used it to identify different relationships given pictures. Angles that add together to equal 90 degrees, they are considered complementary angles. And in the picture there, it shows you adjacent complementary angles, angles that are next to each other. Guys, if you remember from the activity from class, you can also have complementary angles that are part of a larger picture. So I could draw something, maybe not that, something like this. I could have them labeled. Let's say this is 30 degrees and this is 60 degrees. Those are non-adjacent, but they add together to equal 90 degrees. So if they're measurements, the numbers add up to 90, or they're visually next to each other and you see this 90-degree box, those are considered complementary angles. The ones that equal 180, when you put the numbers together, those are supplementary angles. And those angles, I've been moving my picture here a little bit, sorry guys. Those angles add up together to equal 180. Again, this shows you a picture of just two angles that are right next to each other. This could be, you know, something like, oh, sorry guys, I keep doing that. This could be something like 60 and this could be something like 120, which together they give me that 180 degrees. They can be next to each other. They may not be next to each other. Again, you could have a picture, you know, similar even to what I drew before, and let's say this is 120 and this is 60. Again, they're not next to each other, but these two measurements together equal 180. So both of those kind of apply. So a good way I will remember it is that C comes before S in the alphabet, 90 comes before 180 on the number line. So it kind of works in order both ways. So that's a good kind of way to remember that. We also talked about vertical angles and supplemental angles. So congruent means equals, the same. Vertical angles are congruent. And this is the symbol for congruent, is the equal sign with a little tilde above it. So vertical angles are congruent, and vertical angles are angles that are opposite of each other. They form V's like the word vertical. So those two blue dots, those would be vertical angles, meaning if this one's 40, guess what? This one across from it has to be 40. And likewise, going left and right, if this one is 140, the other side has to be 140. So opposite angles are congruent or equal. We talked about if they are next to each other. Okay, now this also depends on if you have two straight lines crossing. I should have mentioned that, sorry. You have two perfect straight lines crossing. Then you will form vertical angles. And then the angles that are next to each other or adjacent are going to be equal to 180. So again, even if I looked at my picture on the left there, or I could rewrite it. Let's say those ones are 40 or 140, and this blue dot is representing 40-degree angle. Again, vertical tells me the opposites are the same, right? But if we're just looking at the ones that are next to each other, those two equal 180. And they show you that rainbow, that protractor, however kind of reached you in class when we talked about it, but those are having to equal 180 degrees. Okay, last but not least, we looked at perpendicular lines. They're two straight lines that form a right angle or 90 degrees. Here is our symbol for perpendicular. And if lines are perpendicular, then they form four right angles. So it looks like this, guys. All four angles would be right angles. So again, this note sheet will be helpful for you when you're taking your assessment. If you're in class, you get participation points for going along with me and filling out your note sheet. If you miss class and you're online, please submit a picture of the cheat sheet so that you can get participation points.